learning, understanding different types of correlation is crucial for building reliable and insightful models. Here are some essential types you should know. 1. Bidirection. Positive correlation. Two variables move in the same direction. As one increases, the other also increases, e.g., ice cream sales and temperature. Negative correlation. Two variables move in opposite directions. As one increases, the other decreases, e.g., unemployment rate and job openings. No correlation. No significant relationship exists between the two variables. Changes in one don't affect the other, e.g., shoe size and political affiliation. 2. Birelationship. Linear correlation. A straight-line relationship exists between the variables. Pearson's correlation coefficient measures this type, e.g., height and weight. Nonlinear correlation. A straight line doesn't describe the relationship. Curves or other patterns might be present, e.g., temperature and plant growth. Monotonic correlation. Variables consistently change together, but not necessarily linearly. Spearman's rank correlation coefficient measures this type, e.g., exam scores and study hours. 3. By data type. Correlation for continuous variables, measured using metrics like Pearson's and Spearman's coefficients. Correlation for categorical variables, measured using techniques like chi-square tests or mutual information. 4. Special cases. Spurious correlation. A misleading correlation caused by a third, unobserved variable influencing both variables of interest, e.g., ice cream sales, temperature, and seasonal holidays. Multicollinearity. Multiple features in a model are highly correlated, leading to instability and inaccurate predictions, e.g., number of bedrooms, and square footage, in a housing price prediction model. Understanding these different types of correlations helps you choose the appropriate correlation coefficient for your data and analysis. Interpret the strength and direction of relationships between variables. Identify potential issues like multicollinearity and spurious correlations. Build more accurate and generalizable machine learning models. Remember, correlation is just one piece of the puzzle in understanding relationships between variables. Always consider other factors, domain knowledge, and additional analyses to draw meaningful conclusions. I hope this explanation helps. Feel free to ask any further questions you might have about specific types of correlation or their applications in machine learning.